Okay, we're going to do lesson 5.3. It's on inequalities in one triangle. And what we do is we compare the values of the measures of the angles of the triangle, and then we're also going to compare the angles and the associated sides. For angle equalities, we have the definition of an inequality. And basically it says that if I have a value, we'll call it A, such that A equals B plus C, then A has to be bigger than A has to be greater than B, and A has to be greater than C because it takes both parts to make A. An example would be that if 5 is equal to 2 plus 3, then 5 has to be greater than 2, and 5 has to be greater than 3. So both of those parts. We also have some inequality properties that are very similar to the properties of equality. Different ways of using inequalities as a comparison would be to say that A is less than B. We could say A is equal to B, or we could say A is greater than B. Just like we had in the properties of equality, we have the transitive property, and that's kind of our linking property. We have A is less than B, and B is less than C. So A is less than C, and that's because they're linked together here with the B. The same is true for a greater than statement. We also have the addition property of inequality, and that's where if we add anything to both sides, then the inequality remains the same, or if we subtract, we also have, it maintains the same inequality. On the first page, we have the exterior angle inequality, and that is derived from when we have the exterior angle theorem, which said in the case of the picture below that if I have the measure of angle 1, it's going to be equal to the sum of the remote interior angles, which would be angle A and angle B. The remote interiors just would not have the same vertex as the exterior angle that it's referring to. And then that's associated to the definition of inequality. So if I have the measure of angle 1 is equal to the measure of angle A plus B, then angle 1 has to be greater than angle A, and it has to be greater than angle B because the two parts make angle 1. In example 1, we want to use that what we know about the exterior angle inequality theorem. So we really have to stick to that because we're comparing the exterior angle to its two remote interiors. So we need to remember that an exterior angle is always greater than the remote interiors. For problem A, it says measure less. We want the angles whose measures are less than angle 7. And angle 7 is an exterior angle. And so it's an exterior angle associated with two triangles, one of them being triangle MKL. So angle 7 here is an exterior angle, and then the remote interior angles that go with that would then be 5 and 4. So what it's asking is, by the exterior angle inequality theorem, which angles have a measure less than 7? Well, for triangle MKL, the measures that would be less than 7 would be those remote interior angles of 4 and 5. Then we have a second triangle that angle 7 is associated with, and that would be angle JKL. So for triangle JKL, it has two remote interior angles that are associated to angle 7, and they are angle 1 and the one created by 2 and 4. So automatically 1 is going to be less than 7, but then we have to look at that 2 and 4. Well, 2 and 4 together are less than 7. So if together they're less than 7, then 2 also by itself has to be less than 7. We already have that angle 4 is less than angle 7 by the previous statement. So we can add that angle 2 is as well. For part B, it says we want to know which measures are greater than angle 6. So angle 6 is an interior angle of, actually let's get rid of this one here, is an interior angle of the triangle, MKL. And so we're looking at comparing it to what would be its associated exterior angle. Now, we do have an exterior angle next to it, 7, but 7 is not, 6 and 7 are not exterior angle and remote interior because 6 is adjacent. So we don't want to count that. Then we have another angle, exterior angle, though, is angle 3. And that's it, because 8 is only a portion of the third exterior angle. So we really want to look at angle 3 here. And then we can see that 6 and 4 are remote interior angles. We just want to know which ones would, what angle is greater than 6. So in this case, the exterior angle 3 is going to be greater than 6. And then again, we can also show how it is part of triangle JKL. Six is again an interior angle, and so we want to look at all of those exteriors. We have 7. We don't have 1 out here. There's not one labeled at least, and then we also have 8. So of the ones that are marked, 8 would be my exterior angle, so it would have to be greater than 6. So basically, when we're given an exterior, our answers will be interior angles. And when we're given an interior angle, our answers will be associated to the exteriors. On the next page, we're looking at comparing angles and sides, and the relationship basically says that whatever the largest angle is, the side opposite that is also going to be the largest side, and vice versa. And whatever the smallest angle is, the side opposite is going to be the shortest side, and vice versa. And that's all these theorems are telling me, that the angle and the opposite side are associated with each other. In example 2, it says list the angles, so this is very important, just pay attention to the wording. List the angles of triangle PQR in order from smallest to largest. Sometimes it'll ask for sides and it'll ask largest to smallest. So we have the angles would be, we're not given angles, we're given sides. The sides are, in order, 7.5, 8.8, and 9.1. In association with that, the opposite angles from 7.5 would be angle Q. Opposite from 8.8 is angle R, and opposite 9.1 is angle P. So for 7.5, 7.5 is the smallest side, so angle Q is the smallest angle. 8.8 is the smallest side, so angle R is the next one, and 9.1 is the largest side, so angle P would come after that. And So there's the relationship. Now we don't care about the sides, we want the angles, but we need to look at the sides to figure out the order of the angles. And then the last one, we're going to work the sides out. So we want the sides, again, shortest to longest, but we don't have all of the angles to help us determine, so we're going to have to come up with that value. We know that the measure of angle F is equal to, or let's, the measure of angle F plus the 45 degree plus the 56 degree would equal 180. And we're going to solve for the measure of angle F. And when you subtract 101, you get the measure of angle F is equal to 79 degrees. Now that's not our answer, but we do need that to help us out. We want to list the sides from shortest to longest, so I'm going to list the angles from smallest to largest. And I would have the 45 degree angle, the 56, and then the 79 degree. And then, because I want the sides, I'm going to name those corresponding sides. So the one corresponding to the 45 is side FH. The one corresponding to 56 is GF. And the one corresponding to 79 is GH. And there's my answer. For our homework, make sure that you're only doing the odds on the attached worksheet.